Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. Today, we are going to solve or to graph, in fact, solve a system of linear equations using graphing again. I have a worksheet here that we will use to illustrate some points that I might have skipped last time. So I will start using the odd number problems. I have problem number 3. It says y equals 2x. Notice that when we have a problem like that, it means, oh, maybe this one is empty. We say y equals mx plus b, right? Y equals mx plus b. So if I have mx is 2x, it means m is 2. I have a slope of 2. For the bottom one, mx plus b, negative 2x, so m is negative 2. 2 is not equal to negative 2, so they definitely intersect. That's how easy you can tell just by looking whether this system has a solution or not. And if it later we'll see what if I have infinite solutions or no solutions at all. Is it the same line or are they two parallel lines? So to plot the first one, maybe I'm going to use the pink color to do that. Y equals 2x, and since there is no y-intercept, meaning the y-intercept is 0, meaning that line passes through the origin. And then 2 means 2 divided by 1, right? Y divided by x. So if x is 1, y is 2. If x is 2, y is 4. It doubles. So the y is double the x, whether it's positive or negative. I know that this line would look something like that, but how exactly depends on the slope. So if I move 1 to the right and 2 up, or 5 to the right and 10 up, or 4 to the left and 8 down, I can use any points like that. 3 points are okay, because if you use 2 points and you don't place your straight edge properly, the line may not be accurate. But if you pick 3 or 4 points, that's more than enough. You know that the straight lines requires 2 points to be fully determined, but we make them 3 just, as I said, for accuracy, no more. And I would plot the line like that. And it's better always to write the equation on top of it. Y equals 2x. And then maybe in blue, I'll do this one. This one has a y-intercept of 8, meaning it intersects the y-axis in 8. And then the slope is negative 2. Notice, I know this is silly, but I have to make it clear. The negative 2 is written as negative 2 over 1, right? Negative 2 over 1, I can write it either negative 2 over 1 or 2 over negative 1. All of these three are the same. We don't like to write, usually we prefer to write it like that, but all three forms are correct. Here I'm saying the slope is negative 2, right? But here I say, every time I move positive 1 to the right, because that's x and that's y, that's x. That change in y and change in x. Okay, so every time I move 1 to the right, I go 2 down because the y is negative. Or if I move 1 to the left, I go 2 up. So they are opposite. You see that all of them mean the same thing. So if I am here, and then I'm going to move, say, 1 to the left, I go 2 up. Or if I move 5 to the right, I go 10 down to negative 2 here. You can make any numbers. Okay, you can move to the right and down or to the left and up. Both of these mean the slope is negative 2. Okay, so let's join these 3 points now. And you can see that the point of intersection here is 2 and 4. Again, you check. If y is 4 and x is 2, 2 times 2 is 4, yes, it's correct. If x is negative 2, then negative 2, I'm sorry, if x is 2. Negative 2 times 2 is negative 4, plus 8 is positive 4. So yes, they are satisfied. So it's really very simple to draw and find the solution. Sometimes if they give you weird numbers so they don't intersect exactly at an integer point, we don't like to use graphing in this case. But how can we know whether we are going to get an integer answer or not? After I do that, I will draw it in a different I'm sorry, I'm going to represent these equations in a different way. For example, here we have number 5. And most people would say, okay, let's solve for y, both equations, to make it y equals mx plus b. No, if you have them in standard form, we said that before. First of all, if the ratio of the x coefficient to the y coefficient is the same in two equations, it means either these two lines are parallel or they are the same line. We'll check that later. But for now, you can do it, by the way, in many different ways. I can divide the 2 by the 2 and the 3 by the 3. In both cases, I get 1. So these two lines are most likely either parallel or identical. Or I divide the x's, 2 over 3 and 2 over 3. It's the same. If this is also 2 over 3, it's the same line. If it's anything else, they are parallel. In this case, I get 2 over 3, 2 over 3, 1 over 3. So they are parallel. If that was an 8, meaning I get 2 over 3, I would say, oh, you tricked me. Give me the same line twice in two different forms, but in reality, it's only one line. But because these three ratios are not the same, then these two lines are parallel. Let's do it. And some people, okay, they would say, oh, so now you are going to put it in y equals mx plus b form to plot them. No, I'm not. I'm going, like we said before, I'm going to call A the x-intercept, and B, as the B is known as the y-intercept. And I say to get A from equation number 1, I divide the right-hand side over the x coefficient, I get 2. For B, I divide the right-hand side by the y coefficient, I also get 2. So 0 and 2 and 2 and 0 are on the line, and I can plot the first line very easily. Here is the line. 2x plus 2y equals 4. Oh, by the way, here we didn't try the equation y equals negative 2x plus 8 in blue. Now, if I want to use another color, and I use, say, this purple one, or I can say for the second one, A equals 12 over 3, which is 4, and B is also 12 over 3, which is 4. So I have a line, a point here, and a point here, and you can see that these two lines are parallel. But that's much faster than if I had said, oh, let's solve this and write it in the form y equals negative x plus 2. So the slope is negative 1, the y-intercept is 2. So you have to do some work to get it in. There is nothing like fancy or nothing, secret about the slope-intercept form. It's just people use it a lot because we write y as a function of x. But if it's not written like that, it doesn't mean I cannot draw it. In fact, this might be even easier if I have it. Notice that if I had moved the y to the other side and get this y minus or negative 2x, it doesn't matter, equals 0, and then say y plus 2x equals 8. right? By moving the x to the left-hand side. I divide the 0 by the x-intercept, I get 0. I divide 0 by 1, which is the y-intercept, I get 0. So x-intercept is 0, y-intercept is 0. It means I'm here. For the second line, I divide 8 by 2, I get 4, which is the x-intercept. I divide 8 by 1, I get 8, which is the y-intercept. So I can find these 2 points quite easily and join them without even bothering about the slope. So I don't need to count. If it's in this form, I simply divide the right-hand side by the x coefficient. So here the solution is 2 and 4. And the type of system is that we have intersecting lines, so we have one solution. Here we have two parallel lines, so no solution. We call it inconsistent, but for you say the type of the system, we have two parallel lines. Let's go to a third one. Maybe take number 7 then. Here is number 7. Y equals negative 1/3 x minus 4. So here the slope m is negative 1/3. Notice y over x. And b, the y-intercept is negative 4. Negative 4 is here. And when you have the slope is a fraction, again, you say, if I move 3 to the right, I go down 1. Or if I move 3 to the left, I go up 1. So notice I am here. So if I go 3 to the right, I have to go 1 down. If I go 3 to the left, I go 1 up. And here is my line. Then we go to the second one. The y-intercept is positive 2. The slope is 5/3. So when I move 3 to the right, I go up 5. If I'm at 2, I go 3 to the, at 0 and 2. I move 3 to the right, it's 3, and 5 up to 7. I move 3 to the left at negative 3, and I go down 5 to negative 3. In fact, it's this point. And here is my second line. Y equals 5/3 x plus 2. And this is a case where if I write it in standard form and I divide the right-hand side by the coefficient of x, I will get a fractional number. So in this case, the y equals mx plus b is an easier way to plot it. So each problem is different. And if you can see that 4 is not divisible by, well, if 4 over 1/3 is 12, so I know it's going to intersect at 12, but 12 is outside the page. Or if I divide 2, notice when you move this, it would be negative. 2 by negative 5/3 is negative 6/5, like negative 1.2, which is this point. It looks like it passes, it's not passing through negative 1, it's slightly to its left at negative 1.2. But if I were using that method, it would be hard to figure out where this point is. So I use the y equals mx plus b. Notice I have the luxury of using whatever I want. We have another page, so maybe we have two problems. The first one says, the first one is given to you as like in the first one is in standard form. The second one is y equals mx plus b. In this case, I think it might be easier to first of all divide the top equation by 2. So that would be 5x plus y equals -3. And then I'm going to subtract 5x from both sides. So I say minus 5x minus 5x. These would cancel, and I get y equals negative 5x minus 3, which is the same as that equation. So that's the same line. If you don't agree, you can write this in terms of, I wanted to write it in terms of y equals mx plus b. So I had 10x plus 2y equals -6. I'm going to divide, as I said, or I can subtract 10x from both sides. So I get 2y equals -10x minus 6. And then I'm going to divide both sides by 2. I get y equals -5x minus 3, which is the same equation. So it's an infinitely many solution because it's the same line. Yeah, it's a consistent system, meaning it has solution, but it doesn't have one solution. It has infinitely many solutions. We said you can have, when you have two lines, you may have no solutions or one solution or infinitely many solutions. Okay? Because the power is 1, so you cannot get more than one solution anyway. Two lines cannot intersect at 2 points. It doesn't make any sense. Unless it's the same line, in which case you have infinitely many. Now when we move to number 11, it says Jack and Jill are competing to see who can sell the most tickets to a dance. Jack sold 22 tickets and then 30 per day after that. Jill sold 53 and then sold 20 per day after that. Define two variables. Notice that they instantly solve this at time 0, right? 22 and 53. So that's not a variable. That's a constant. I know it. Oh, that's the y-intercept. Okay, so let x be the number of days in which Jack sold 30 tickets. And let y be the number of days Jill sold 20 tickets per day. So 20 tickets. Write two equations to represent the number of tickets each person sold. So Jack has sold 22 plus 30x. And Jill sold 53 plus 20y. And that's basically it. They don't ask about anything else, so there is nothing to solve. And that's it. So hopefully that clarified, that you have generally two ways to plot. If you see that the constant number, which is the 3, is divisible by 1 and 5, you use that method. But 3 over negative, or 3 over, negative 3 over 5 is negative 0.6. It's not easy to plot. So in that case, we use y equals mx plus b. But in the previous problems, for example, not this one, the first two, especially here, if I say y minus 2x is 0, 0 over anything is 0, so it passes through the origin. For the other line, 8 over 2 is 4 for x, 8 over 1 is 8 for y. So I go to 4 on the x-axis, 8 on the y, and join them without calculating any slopes. So you have really two ways of graphing a system of linear equations. The point of intersection is called the solution, okay? And if they don't intersect, there is no solution. If they coincide, there are infinitely many solutions. I hope that clarified this thing. And then we are done pretty much with the linear. How do I represent a line or two lines either, and then if I have two lines, how do I find the solution? Using substitution or using elimination, and now using graphing. So we are done with this part of the course. Next time we are going to move to something new. I hope you are still engaged. I wish you all the best. See you soon. Bye.